Jamie, and I'm here today to introduce you to our new electronics system called Spike, and also show you some of the changes we made along the way. The Spike pinball system is a rugged, distributed, and embedded platform custom designed for the rigors of the pinball machine environment. Spike takes advantage of current technology to deliver an immersive pinball experience that supports modern features, reduces cabling, and increases serviceability and reliability. What we remove from the SAM system: large CPU board, I/O power driver board, fluorescent tube, sockets and hardware for mounting the tube, the starter, the ballast. Half the amount of wire is gone. Here is the 48-volt switching power supply. Service box has been removed from the cabinet and is now located in the back box. Moving the service box eliminates high AC voltage in the main cabinet. Main power fuse is located on the service box, 8-amp slow blow fuse for domestic games and a 5-amp slow blow fuse for international games. Also located on the service box is the 110-volt AC service outlet for domestic games only. Power distribution board. This board is enabled by the power interlock switch, which is located on the hinge of the coin door. When the coin door is closed, this activates the power interlock switch, and 48 volts is supplied to both the PLAYFIELD and cabinet node boards. When coin door is open, this deactivates the power interlock switch and disables the 48 volts to both the PLAYFIELD and cabinet node boards. New location of power switch. Our new CPU board features a high-speed microprocessor with expanded memory and automotive-grade circuit protection for LEDs, switches, and solenoids. LED indicators. 48 volts in from power supply, 24 volts for audio, 9 volts for node bus power. 5 volt powers all of the logic on the CPU and dot matrix display. Status LED. Constant double blink indicates operating system is running. Net stat, network status. Constant blinking indicates activity on the Spike bus. RX, CPU receiving data from the PLAYFIELD and cabinet node boards. TX, CPU transmitting data to the PLAYFIELD and cabinet node boards. Identifying connectors and parts of CPU board. CN7, 48 volts in from power supply. CN23, display ribbon cable connection. CN24, 5 volts and ground to the LED display. BT1, battery for real-time clock. SD card, game software. CN25, dedicated switches in. These are your diagnostic volume switches located on your coin door. CN22, RJ45 jack, node bus to PLAYFIELD node. CN3, RJ45 jack, node bus to cabinet node. CN2021, USB port, for software updates, audit dumps, and expansion modules. The game software may be updated in the traditional method by inserting a USB stick and following the on-screen prompts. The game software can also be updated by simply swapping out the SD card with the card that already has the update. When the SD card method is used, the game is ready instantly upon power on. S2, 8-bank dip switch for setting country codes. CN18, stereo headphone jack. CN1, back box 2-channel amplified speaker out. CN4, cabinet 1-channel amplified speaker out. Benefits of Spike: increased reliability. All inputs and outputs are protected against shorts with a built-in automotive-grade protection circuit. LED to light the back box, no fluorescent tube. Can operate more Spike games on a 20-amp circuit, 6 versus 3 on SAM. Less power consumption equals less heat. PLAYFIELD uses less wiring, half the amount of wire that was used in SAM due to the modular node boards. Types of modular node boards. 8-driver node board. This node board can operate 8 coils, 8 switches, 16 controlled LEDs, and 1 GI string of 18 LEDs. 4-driver node board. This node board can operate 4 coils, 16 switches, 15 controlled LEDs, and 1 GI string of 18 LEDs. 32-switch LED node board is not fused but powered through the 9-volt Spike data cable. This node board can operate 32 switches and 32 controlled LEDs. Communication between the CPU and the PLAYFIELD node boards is established through the RJ45 Category 5 data cables. LED indicators on the node boards. Red LED indicates that the 48 volts is present. Yellow LED, constant blinking, indicates board is functioning and communicating. Green LED indicates that the 6 volts is present. Main cabinet, no transformer. Eliminating the transformer reduces weight and heat. Communication between the CPU and the cabinet node boards is established through the RJ45 Category 5 data cables. LED indicators on the cabinet node boards. Red LED indicates that the 48 volts is present. Yellow LED, constant blinking, indicates board is functioning and communicating. Green LED indicates that the 6 volts is present. This node board controls all cabinet switches except flippers and diagnostics. Diagnostics run directly to CPU via CN25. The lower flippers run off of the lower PLAYFIELD node board. CN11 is your ticket dispenser connection. CN6, left cabinet switch inputs. CN13, RJ45 connector for node data bus. CN12, diagnostic volume switches to the CPU. CN14, 48 volts power in. CN2, shaker motor connection. CN7, right cabinet inputs. CN4, meter 2. CN3, meter 1. CN10, input for diagnostic volume buttons. These inputs only pass through the cabinet node board. CN5, coin door connection, includes coin switches and coin door LEDs. CN9,